Hi everyone, this is Education for All. We started with partial fraction decomposition. We have gone through the introduction. We are now going to look at one problem here and then we'll try to solve it. We are given this function here, 3x plus 5 divided by 2x squared minus 5x plus 3. So we want to decompose this function into smaller bits. That is all what we do in partial fractions. We want to break it down into simpler form, what we say into rational forms instead of irrational. Change it into rational forms. You know, something you can P all over Q, you can put it in this way, to simpler form. You know what rational numbers are, for example, is fractions, in which case, if you have, for example, like 3.6251342, and you have 3.626262. These two numbers, this one here is an irrational number. This one here is a rational number. Why? Because this can be represented as a fraction, like this. You see it's repeating, 626262 is repeating after the decimal point. So this can be represented in the form P all over Q. This one here is not repeating. It keep getting different numbers, 6251342. So this is not a rational number, it's irrational because it can't be written in this format. Once you understand this, then you know what rational numbers and irrational numbers are. Root 2 is irrational because it's an imperfect square, while root 4 is rational. This is rational, this is irrational. You cannot simplify this into a fraction. This one, you can simplify it as root 2, root 4 is 2 over 1, it's a fraction. So this is just a distraction because we are using the word rational here. So I want you to understand what it means. So now we want to decompose this function. So what do? We have it here as 3x plus 5 divided by x minus 1 into 2x minus 3. So what we do in decomposing this fraction, we now know the exponent of the unknown here is less than the exponent of the unknown at the bottom. If you expand this, you get x squared. This is x, so this is good. There are various techniques we use. The first one we are going to look at here, we call it equating. We are going to equate the equating coefficients, the equating coefficients. Equating coefficients. This is the first method we are going to look at here. So now we know this can be broken down into A, we give it an unknown all over x minus 1 plus B all over 2x minus 3. And then we want to find, because we want to break it down into fractions. So we don't know what I is, we don't know what B is. This is what we are going to find using the method equating coefficients. Method of equating coefficients. So what do we do next? You know what we do with fractions. So now what we do, I want to multiply here everything by x minus 1 plus 2x minus 3. So that, or you multiply this part here, 3x plus 5, you know you have this x minus 1 all over 2x minus 3. I want to multiply this so that I clear this fraction by x minus 1, 2x minus 3. So this is all over 1 here, so that this will cancel. So what will remain here is just 3x plus 5. So because I'm multiplying by x minus 1 here, I should also do on this part of the equation. So you multiply everything here by x minus 1 times 2x minus 3. If you do that here, what you have done on this side there, if you do it here, now you multiply a over x minus 1 times x minus 1 times 2x minus 3. The x minus 1 will cancel. So what will remain here is just a times 2x minus 3. What will remain here, we are also multiplying this, everything here, everything there. I'll make it simple here. We are multiplying everything there with this line. By x minus 1 times 2x minus 3. Yeah? So if you do that, you multiply everything all over 1. This, which was a fraction. So you know, all this will cancel this one. So what will remain here is just 3x plus 5. This sign means equivalent. Equivalent to. And then, when you multiply this by this one, this will cancel this. So what will remain, you will have a into 2x minus 3 plus. And then this one here, you will have b. The 2x minus 3 will cancel. So we just have b into x minus 1. So this is what you get. This is what you get. So let's now expand this fraction here. So we'll have 3x plus 5 equivalent to 2, you expand here, so you'll have 2ax, 2xa, let me say 2ax, it doesn't really matter, minus 3a, then bx plus bx minus b. So you have 3x plus 5 equivalent to the x's, bring them together, the x's. So you have 2ax plus bx. So, and now the x's, we bring them together here. So now the ordinary numbers, you bring them together again. So you have minus 3a minus b. So what this one is telling us now, this is the point where we apply this method of equating coefficients. The 3x, this has x, this has x, this has x. So if you're equating these coefficients of x's, so now it means here we'll have 3 is equivalent to 2a plus b. Anything that has x. Yeah? And this is our equation 1. And this is just an integer. Yeah? Without any x attached to it. So it means this one here, the 5, is equal to what is left without x. Right? So 5 is also equivalent to minus 3a minus b. And this is our equation 2. So we have 2 equations here to solve. Right? If you have 2a plus b equals 3, that's equation 1, and you have minus 3a minus b equals 5, that is equation 2. So you can use your knowledge in solving simultaneous equations to solve this problem. Yeah? Here, whatever has x, equate it to what has x on the other side of the equation. What is ordinary here, we call it constant. There is nothing on it, it's just a number 5. Equate it to everything that has constants, because this b is actually minus 1b, but we don't write it, so you can see these are constants. There is another one here, 1bx, sorry, 3a, 1b. These are constants. Yeah, this has coefficients. So now, using our idea from simultaneous equations, we know when you have minus b here plus b here, you can just add the 2 equations and the b's will cancel themselves. So if you add 2a minus 3b minus 3a, you get minus a, and here you will get plus 0. If you add, you get 8. So therefore, a is minus 8. Therefore, a is minus 8. So if a is minus 8, you can use any of the equations to find b. So let's use the top one. We now know a is minus 8, so putting minus 8 here on this equation from equation 1, still 1, still 2. If you put a equals minus 8, then you will have 2 minus 8 multiplied by minus 8 plus b equals 3. So this gives you minus 16 plus b equals 3. So if you bring the 3 over, so if you bring the 16 here, so b will be equals to 3 plus 16, which is 19. So therefore, b is equals to 19. So having found the values of a and b, you now come to this equation here to state your values. So you now know that when you decompose this function, which is equal to a over x minus 1 and b over 2x minus 3, you will have, I'll put the equivalent, a minus 8 all over x minus 1 plus b, which is 19 all over 2x minus 3. So because of this minus sign, you can exchange the positions of, if you want to, this function. It doesn't matter as long as the denominator goes with the numerator. So this can also be written as 19 all over 2x minus 3 minus, because of this, 8 all over x minus 1. You can either leave it like this or like this. So that is the solution to this problem. Thanks for watching. Bye-bye.